All right, so let's talk about what is the machine learning pipeline, or what is the life cycle of machine learning, right? You would see a few questions around it, so I would say pay a little bit more attention to it, right? So I'll break it down into seven, distinct areas of this. Basically, this falls into domain one, task statement 1.3, so you should pay a bit attention. So, and a machine learning pipeline is a sequence of steps that takes you from identifying a business goal to operating a deployed machine learning model. Think of it as a life cycle where parts repeat for continuous improvements, as it shows in the diagram. It starts with defining the problem and business goal, and then collecting and preparing data, training the model, deploying the model, monitoring the model, and those basically some of the key steps. And let's look at what happens in each step, right? So each stage involves multiple tasks and considerations requiring in-depth exploration of successful ML environment. So identifying the business goal. The first step is to clarify what problem you're trying to solve and the value it brings. So be specific, define success criteria and business matrix so you can evaluate whether ML is the right solution. Maybe it's not. So key considerations would include is collaboration with stakeholders. So you need to basically understand it from the perspective of a user, a buyer, a technical person who's going to be managing it, right? So you need to have collaborate with several different stakeholders. And then you have establishing success metrics. So what will they do right, or how do you know that you've done something good, right? Is it good or bad? How do you measure good? Can you quantify it? Is it going to increase my revenue by 3%, 4%? If I'm selling shoes today, would I be able to sell more shoe polish along with it, right? So, and then aligning business goals with technical objectives. Don't do the other way around, all right? Don't find a technology first and then go looking for a business solution. A business problem to solve that, right? So if you start with the problem and then get to it, right? The second step is gathering and preparing data, right? So high quality data is crucial for building an effective model, but everybody is awash of data, but it's really hard to get and normalize it and make sense of it. So you have to have enough relevant and diverse data to avoid bias, right? So this phase involves identifying and accessing the data sources, performing data cleaning and transformation, splitting data into training, validation, and test sets, right? So, all right. So how do you, the next stage of the ML life cycle would be collecting and processing and training data, right? So collecting data, the first step in this stage is, of course, to identify the data, right, and determine how to collect it. This would involve understanding the sources where the data is generated and stored. Data collection considerations would include, right, is the data streaming or batch based, or how frequently should data be collected, or configuring an extract ETL, extract transform load process to centralize the data of multiple sources. Then you have to also think about labeled versus unlabeled data. We talked about it previously. So understanding whether your data is labeled or unlabeled is essential, right? Labeling can be a lengthy process, as accurately labeled data may not be readily available, right? So how do you do data prep steps? So data preparation involves data processing, so cleaning data, handling missing values, and normalizing data sets. After that, you do feature engineering. Feature engineering basically selecting relevant features and creating new ones to enhance model accuracy, right? So the tools for preparation would include like AWS Glue, which is a fully managed ETL service for data discovery and preparation. Or AWS Glue Data Catalog manages materials for data stored across multiple sources. Or AWS Glue Data Brew, visual data protection tool for cleaning and transforming data. So, as we said, data preparation steps would include, data processing, so cleaning data, handling missing values, and normalizing data sets, and also feature engineering, like selecting relevant features and creating new ones to enhance accuracy. As I had mentioned, AWS Glue is a fully managed ETL service, so you should definitely take a look at that. AWS Glue Data Catalog, which manages metadata for data stored across multiple sources. And also AWS Data Brew, which is a visual data preparation tool for cleaning and transforming data. Okay, and as I previously mentioned, that you want to split your data across training, validation, and test data, and then so that you can have a good set. And then in your feature selection decision, just make sure that you're not over engineering. You're just picking up the relevant features that would actually help you, right? So other tools that you should be aware of would be SageMaker Ground Truth, right, for creating high quality labeled data sets, or SageMaker Canvas, which is a visual tool for feature engineering and data analysis, or SageMaker Data Wrangler. Remember these terms because you would be seeing them in your test. Simplifies, these names of the products and services. So SageMaker Data Wrangler simplifies data import, transformation, and cleaning. Okay. And another thing is that to collect and process to build a successful machine learning model, right, it's crucial to identify the data you need in advance and determine how to collect it, as we talked about, right? Identify data sources, right? Where data is generated and stored, and data types like streaming versus batch data, ETL, right? And in data preparation, we definitely need to think about EDA, which is an exploratory data analysis, which uses visualization tools to understand data better. And then for data cleaning is important to divide the training 80%, validation 10, and testing 10, right? So that's the splitting part we already talked about. So feature identification, is extremely important, and I'm going to restate it, that choose relevant features for model accuracy. Don't make it a science project. Don't throw in feature just for the sake of it. And reduce feature intentionally. Reduce it to limit features to reduce memory and computing power, right? All right, so I'll see you in a bit. All right, so let's think about the next phase of ML pipeline, which involves training, tuning, and evaluating the model. So this phase involves an iterative process where the machine learning algorithm upsets a set of numbers known as parameters as weights. So the training phase, basically, in the training phase, the model is trained by adjusting its parameters so that its output matches the expected results. And there will be multiple iterations are required since the algorithm initially has no knowledge of optimal parameter adjustment, right? And the process stops when a defined number of iteration is reached or the error rate falls below a target value. So that's the training phase, right? And then you have the tuning phase. In the tuning phase, multiple algorithms and settings are tested in parallel to identify the best performance model. So you're right. So external settings called hyperparameters, they affect model performance. For example, the number of neural layer. So the optimal hyperparameter values are identified through multiple experimentations. Now, you could use Amazon SageMaker for model training, and that's really for training job creation. So it would specify S3 bucket containing the training data. It will define the compute resources required, and tell the algorithm using a Docker container image, right? And hyperparameters are specified during the job setup, by the way. And then execution, SageMaker launches a machine learning compute instance and runs the training code. And training model or artifacts are saved to the specified S3 bucket. So once you have a fully trained, tuned, and evaluated model, the next step is to deploy it for use, right? So the primary decision is whether you need batch or real-time inferencing or a combination of both. So let's look at the batch inference, ideal for processing large data sets where results can be delayed. For example, running inference overnight on sales data. Real-time inference required for immediate responses, such as GenAI applications where client interaction happens via a REST API, right? So a web application can send a post request containing input data to an endpoint, which forwards it to a compute resource running the model. The model processes the data and returns the result. All right, so that's kind of a real, an example. So AWS tools for inference that you could use would be Amazon API Gateway. It manages client infrastructures and forward requests. And Lambda can run model inference for several serverless setups. And then SageMaker, of course, provides a fully managed service for deploying models with minimal operational overhead. So when you're deploying with SageMaker, right, SageMaker deploys models using Docker images, all right? And inference options, both batch, async, serverless, and real-time inferences are available. And batch transform, right, best for, as I said, offline, large data sets. You don't need an immediate response. Async is queries requests with large payloads and scales during inactivity. So if you want to do a backup job, you may want to do it during night if there's not a lot of activity, right? Serverless inference, no need to provision compute instances, good for intermittent traffic, right? So that's why you would use server inference. And real-time inference provides you with persistent low latency endpoints for immediate responses. So SageMaker also offers an inference recommender tool to test different configurations and identify the optimal setup for your model. Okay. So let's talk about monitoring. So no matter how great a model initially performs, its performance can degrade over time due to data quality, and model bias issues. So the final stage in the ML lifecycle involves monitoring the model's performance in production. All right, so the key concepts in monitoring would be data drift, which means significant changes in data distribution compared to the data training, right? Or concept drift, changes in the properties of target values, right? So monitoring system components could be like capturing data, comparing data to training set, defining rules for issue detection, and sending alerts for performance degradation. Okay? And Amazon SageMaker Model Monitor basically automates model monitoring by collecting data from endpoints and comparing it against a baseline and detecting violations based on built-in custom rules, right? So alerts can be sent to Amazon CloudWatch for further actions like retraining. Right, so machine learning ops or MLOps brings software engineering best practices to machine learning key principles, like for example, automation, right? It reduces manual tasks through automated pipelines. In version controlling, it tracks training data and model configurations. And monitoring and retraining, of course, is automating process to data drift and model degradation, right? So if you see that data is drifting or your model is degrading, so you can automatically respond to it. Okay. So the benefits of machine learning ops, I mean, there are many. So from a productivity perspective, it automates ML infrastructure provisioning, right? Repeatability, yeah, you know, kind of like rinse and repeat. So ensures consistent and repeatable model training and deployment. And compliance, yeah, enhances auditability by versioning input. So you can go back and show your auditors every one of the versions of the outputs and models. And it of course improves quality by enforcing policies for data model and quality. So Amazon SageMaker pipeline automates ML workflows, including deploying models for real-time and batch inference, tracking model lineage and artifacts, and providing reproducible and auditable ML pipeline, right? So pipelines can be created using the SageMaker SDK or Python, or defined using JSON. So pipelines can be visually monitored and managed in SageMaker Studio. So as I was saying, right, SageMaker automates workflows, deploys models for real time, tracks model lineage and artifacts, and provides a reproducible and auditable pipeline, right? So some of the responsibilities, if you think about it, right? So MLOps services and repositories, I meant. So SageMaker Feature Store, which is a repository for storing feature definitions of training data. And then SageMaker Model Registry, which is a centralized repository for trained models and version history. And then you have SageMaker Pipelines, which basically automates machine learning pipelines, as we discussed earlier. Then you have AWS Step Functions, which provides serverless workflows with a visual drag and drop interface for integrating with your services, right? And then you have Apache Airflow with Amazon Managed Workflows, which is an open source tool for authoring, scheduling, and monitoring tasks. So let me explain model evaluation matrix and break it down for you. So think of the confusion matrix as a report card for how well our model is doing at classification task. Okay, it's a grid that shows us all the ways our model can be right or wrong. All right, so let's break it down with the real world. For example, say predicting if an email is a spam or not. First, let's understand the 4 key outcomes we track. So true positives are when our model correctly identifies something, likely correctly flagging a spam email or a spam. True negative are when it correctly identifies when something isn't present, like correctly letting a legitimate email through, right? Then we have our mistakes, false positives or false alarms, like marking a legitimate email as a spam, and false negative or missed detections, like letting a spam slip through into your inbox. Okay, so now let's talk about the matrix we use to make sense of these numbers, right? So accuracy is the simplest. It is just how often our model is right overall. But accuracy alone can be misleading. Imagine if only 1% of emails are spam. A model could achieve 99% accuracy by just marking everything as not a spam, right? This is where precision and recall come in. So precision asks, when our model says something is spam, how often is it right? Is it like it is like measuring how trustworthy our spam alerts are. Recall, or also called sensitivity, asks, out of all the actual spam emails, how many did we catch? Is it like something? Is it like measuring how thorough or our spam detection is, right? The F1 score is what we use to balance precision and recall. It's like a harmony between being thorough and being trustworthy. High F1 scores means our model is doing well at both. Okay. when it comes to trade-offs, right, it's like a seesaw. High precision means very careful about raising alarms. We might miss some spam, right? But when we say something is a spam, we are usually right. So high recall means we catch almost all the spam, but we might accidentally flag some good emails too. So the F1 score helps us find the sweet spot between these extremes. So in practice, which matrix matters most depend on your specific needs. For medical diagnosis, you might prioritize recall because missing a disease, false negative, could be catastrophic, right? For spam filtering, you might lean toward precision balancing. Falsely blocking important emails could be more problematic than letting through occasional spam.